Hi everyone, this is Team 2's interim presentation. Our team members are
Jake Tercios,
Peter Wynn,
Jennifer Park,
Balpreet Singh,
Weston Deach.
We chose to analyze and redesign an outdoor grill.
Our target audience consists of two groups, primary and secondary customers. Our grill is primarily for those who enjoy outdoor cooking. The grill caters to those who will use it mostly for outdoor cooking and for a variety of food. The grill is very versatile, maneuverable, and easily to use outside. The secondary customers consist of businesses such as large food trucks, large kitchens, or catering services. Our grill is designed to fit in a countertop area. The estimated production volume is 50,000 units.
Here you can see the exploded view of our outdoor grill assembly. Please note that we will not be modifying the heating elements or the caster wheels as they are purchased components within our assembly.
The fast diagram shown describes the functions our grill product must perform. The sole task function of the grill is to cook food.
we have developed two fishbone assembly sequences that show how the grill can be assembled. The top left of the slides shows the assembly as we progress through the sequence. We start with the bottom shelf and attach a sub-assembly of caster wheels and legs. Next, we add the bottom supports and attach a sub-assembly of tabletop legs and supports that will allow the drip trays to be laid on top. We then attach a sub-assembly consisting of the front, side, and back panels that will house the grill. We then attach the tube burner assembly to the inside and attach the cooking grate atop. Next comes the round burner assembly along with the burner grates. Finally, we attach the top edge and grill knobs. In assembly sequence 2, we start with the bottom supports and lay the drip trays on top. Then we construct the frame of the grill consisting of the front, side, and back panels along with the top edge. We then affix tabletop assembly legs and supports to the bottom of our assembly. Next, we attach the grill knobs and tube burner assembly. After laying the cooking grate on top, we attach the round burner assembly and install the burner grates. Our assembly is then placed atop a sub-assembly consisting of the bottom shelf, legs, and caster wheels. After comparing the two sequences, we found sequence 1 to be more effective due to an ease of transferring and handling, along with fastening and joining.
This chart displays the function component mapping matrix. This matrix connects the components of the grill to the leaves of the fast diagram. As you can see, the function relating the most components is the insulation of heat. And the functions with the least amount of components are measuring temperature, reducing size, and containing food. A redesign may be warranted as insulation of heat shares many components.
Here's our bill of materials. A majority of our materials would be made from aluminum and processed using sheet metal working. Notably, the knob will be injection molded and the burner and cooking grates will be sandcasted. We assume our assembly for the grill to be done manually with a labor cost of $16 per hour based on a 2024 statistic for assembly line workers' wages. It should be noted that a few of these parts will be considered to be purchased. That includes the round burner assembly, tube burner assembly, caster wheel, along with the fasteners. The total cost of each grill assembly is $167.61. We categorize each component into the DfM quadrant according to its relative manufacturing, assembly costs, and functional importance. Since the round burner assembly and tube burner assembly are purchase components, we have decided to look into redesigning the front panel, cooking grate, top edge, burner grate, back panel, and both drip trays in order to reduce the cost of these components. We also consider a redesign of each tabletop component in order to reduce the number of parts and lower assembly costs.
The functions from our fast diagram that differ between our customer groups are reduce size and ease movement. From the function component mapping matrix, the modules that support these functions are the bottom shelf, caster wheels, legs, tabletop legs, and the long and short tabletop supports.
Looking at the assembly sequence, both assemblies have a nearly identical sequence until the last 3 steps, where the wheeling subassembly can be omitted. While the differentiation is already delayed, we can still look for potential optimization in early parts of the assembly based on ease of testing along with tooling access.